to the reviewer once again. This is the second video presenting the symptoms management application prepared, implemented by me for the last course in the mobile cloud computing program held by Coursera for the capstone project. So in this video I will present the backend application I have prepared, and the backend application is quite generic and it's a proper enterprise Spring application featuring multiple layers and featuring good practices for the purpose and design patterns for the purpose of easy maintenance and possibility of flexible further development of the application. So what you can see on the screen is my IDE, and let me present first on the right the database structure as reflected in the database. So I have decided to use the most simple database, HSQLDB. I have also run this application on the real cloud VPS server together with the backend application, and the backend application is running there at the moment. All my tasks and the presentation of the application that will be shown in the third video have been done using the production application, the production instance of the application running on the mentioned VPS server together with the production database that is actually shown on the right hand side of the screen now. So starting from the bottom, starting from the model, data model itself, let me present you the tables. The central point of the data model is the table of prescriptions, and it contains the time when the medicines needs to be taken, the patient, relation to the patient who should take the medicine, as well as dosage of the medicines and comments, doctor who prescribed it. And there are many external relations from other tables to this prescription table. The queries executed are collecting data from multiple tables related to this particular one. So the table of prescriptions is central in the data model. There are separate tables related medicines and questions with prescriptions. There's a separate table for questions, separate table for users. Please note that the table of users and the corresponding entity, the structure of entities, are creating the polymorphic structure of entities with the use of the joins table inheritance strategy. So the user is a topmost structure, and both doctors and patients are inheriting from it. The user contains generic user information like first name, last name, email, username, password, photo, which was planned to be included as well, a type of user, which is either doctor or a patient. Then there's patient-doctor relationship between patients and doctors, so that we can associate patients to doctors. Further, there are medicines. Notification reason is the reason used by the analysis to associate with found with the notification which is created when checkings are fulfilling the notification criteria. For instance, when multiple checkings with or three checkings with the severe pain level are discovered, the notification for certain notification reason will be created and put in the corresponding notification table. And this is the notification table. Notifications are related with check-ins, obviously, because check-ins are being analyzed, and with prescriptions, because I have extended the concept of notifications in the application, and also included notifications of not properly checked any prescription. So if the user doesn't fill the prescription by the time of prescription or by the next analysis time, a notification will be triggered and possibly delivered to the user. There are also questions and answers in the model, and the diagram of the data model has been presented in the previous video, so I suppose that its introduction is enough, and let me continue with the presentation of the general backend application structure. It is a correct, proper Spring application with I would say canonical, proper sections, layers. So first there's a model layer, repository layer. So I have distinguished set of repositories mapping to previously introduced database tables and elements of the model, and these are Spring Data JPA repositories. I have distinguished services, and services are quite simple at the moment, but apart from the notification service, which contains timers and quite much logic for the analysis of check-ins, the entities mapping onto the tables directly, DTOs, which are not mapping into entities and their relations in one-to-one mapping. They're different, they're much more simple than the complicated database model. They are not related, they are simplified to the point that the relations have been replaced with the IDs of list of IDs of related elements in order to save and transfer. So this is the model. After BAF services, there are facades which are translating entities to simpler DTOs. Then we have multiple Spring controllers and a set of an authentication configuration. Please note that all the controllers and all the data traffic is transmitted over the secured HTTPS connection, and all the requests require the OAuth token. So all the requests are authenticated. The user needs to have the client application needs to have the authentication token, needs to be properly authenticated in order to use any one of the application backend functions. So let me also introduce tests. There are separate module tests and testing queries because I have actually used a lot of named queries Spring databases, deeply named queries, and there are multiple integration testing the separate controllers. Actually, the application is very well tested, so that after finishing it, apart from one logical extension I needed to provide to add, I just ran the application on the VPS server mentioned previously, and it is running until today, and I was able to create the entire front-end application based on once created, properly designed backend application. There are also separate configs for the backend integration test and client classes, which are required to in order to communicate with the backend securely also in test, because the integration tests are testing not only the logics of the application, but they also are testing the security system. So the application run for the purpose of integration test includes the OAuth server, and the test itself needs to authenticate in order to test the application logic. So let me present now excuse me for a moment. So let me refer briefly to the requirements from the backend perspective. So requirements are not only front-end related, I mean the symptoms management application requirements, but they are also backend related. So one of the requirements is that application interacts with at least one remotely hosted Java Spring based service. There are a lot of Spring services provided by the backend application. Application interacts over the network via HTTP. Here the entire functionality is HTTP protocol based. Patient has some identifying information such as first and last name, date of birth, medical record number, and this is the information included in the user and patient tables. Then during the checking, the patient is asked the number of questions about medicines and additional questions, so the requirements are obviously fulfilled from the backend side, because the backend allows to store and retrieve check-ins as well as questions. The application finds a doctor, which is different user from the patient. Yes, there's a clear separation between patients and doctors in the backend, in the data model. The application allows doctor to monitor patient check-ins. Yes, backend properly supports the retrieval of check-ins associated with the patient, and it allows for the possibility of arbitrary analysis of patient check-ins. The backend also provides analysis of patient check-ins and triggers notifications in case of extended suffering periods reported by the patient. And finally, the backend is accessed through secure HTTPS. So all those mentioned requirements have been or are fulfilled by the backend application I have created. So now let me show you several details of the backend application. So please know that it is very much test and not production password. It's not. It doesn't actually identify the real certificate used. It's fake. So this piece of code here, embedded server container customizer, customizes the embedded Tomcat server, which actually runs the secure HTTP connection for the application, for the backend application. Multi-part config element is for the picture, for the graphic upload, like application pictures. There are a lot of Spring Boot annotations included. Now, typical repository, it's not a service. Let me show you the repository. There are simple repositories, however they are quite complicated repositories as well. For instance, in the patient repository there is a method allowing to retrieve patient based on matching the names and first and last names. The method is used for the purpose of the patient search required included in the application requirements. So whatever I'm using named queries with named parameters, this is my way of making use of the complicated database model in Spring Data JPA repositories. Well, I will not show all the repository methods, and the reviewer is welcome to study the repositories on its own. Now, I've mentioned the DDL file creating the database structure, which is backing entities and the entity model. This is it. I'm creating all the tables separately with indexes, foreign keys. The database is properly initialized as well. So it's the initialization of the database is used for the purpose of front end, of back end testing, as well as in production for the purpose of having some data in the database in order to test the front end with it. So let me come back to the database, to the application structure, user entity. Please note the inheritance strategy, allowing to distinguish patients and doctors. Wherever I can, I'm actually using the Fluent interface proposed or shown in the third course of the mobile and cloud computing program. It's very useful, very helpful. Let me show you services. The notification service. Well, a lot of values configuring the analysis, a lot of logics allowing to filter out extended periods of suffering indicated by patients, allowing to trigger notifications for read by the front end. Please note that allow is configured slightly differently than in the exemplary applications. that we have studied in the third course of the program, and it includes the real user repository. Actually, the usernames and passwords are read through the user service from the database. And let me show user service. In fact, implements the interfaces required by the Spring Security in order to feed cleared client authentication data. And finally, controllers. I'm using interfaces for controllers in order to define paths, and I'm using the implementations in order to include the logic of the controller, which should be very simple, which is always very simple, as well as all the necessary annotations like response multiplied variables, request mappings, and so on. So actually there are 6 controllers at work. And in the 6 controllers, I think I have like around 30 REST web services. So that concludes my introduction of my backend applications. A backend application, cloud application, serving the mobile Android applications, which are the visible part of the symptoms management application. I hope that my introduction is sufficient to and it exhaustively presents the fact that I have included all the functionalities of the backend together with sufficient data model that properly supports the symptoms management application requirements. Thank you very much.